day, air pollution is becoming an urgent environmental and public health concern in cities and industrial areas around the world. Every day, vehicles, factories, and power plants release invisible pollutant into the air, affecting the quality of the air we breathe and causing harm to both humans and the environment. I'm Nur Alizati reporting on the sources and effects of air pollution and how understanding pollutants can help us control them. Air pollutants are substances released into the environment that negatively impact human health, ecosystem, and climate. In urban and industrial areas, major sources include vehicles, factories, and also power plants. Vehicles mainly emit carbon monoxide and nitrogen oxides, while industrial process and power plants release sulfur oxides and particulate matter including PM2.5 and also PM10. Carbon monoxide is a colorless and odorless gas that disperses easily and it is stable in the atmosphere. Particulate matter such as PM2.5 and PM10 are tiny solid particles suspended in the air. PM2.5 can travel long distance and penetrate deep into the lungs, while PM10 slightly larger still poses health risks. Sulfur dioxide dissolves in moisture-forming acid rain, and nitrogen oxide react with sunlight and VOC to form secondary pollutants such as ground-level ozone. Now that we understand what air pollutants are, their sources, and how they behave in the environment, let's take a closer look at how these pollutants affect real communities and cities. We will examine 3 case studies in Malaysia, Vietnam, and also Indonesia to explore the impact of both primary and secondary pollutants on air quality, public health, and the environment. Through this example, we can better understand the challenges of managing air pollution and the importance of emission control technologies.
The first case study examines air pollution in Bukit Rambai Mahakal and Mount Johor. These areas are affected by urban growth, industrial activities, and seasonal haze from regional forest fire, which is significantly impact air quality and public health. Air quality data, including the Air Pollution Index, API, and PM10 were collected from monitoring stations between 2015 and 2018. Other pollutants such as O3, NO2, SO2, and carbon monoxide were also analyzed using a statistically and mean-based tool. The results show that Bukit Rambai recorded a higher average API of 48.4 compared to 38.3 in Muar. PM10 level were also higher in Bukit Rambai at around 45.4 per cubic meter, while Muar recorded about 39.4. During HES period, Bukit Rambai experienced 37 unhealthy air quality days, almost double the 19 days recorded in Muar, indicating more severe pollution episodes in industrial areas. One analysis revealed that the northeast wind and low wind speed caused the pollution to stay longer in the area, especially PM10, to accumulate in urban areas. This shows the combined effect of local emission and transboundary haze. Higher pollution levels were associated with increased respiratory complaints and outpatient visits. Vulnerable groups such as children, the elderly, and those with the pre-existing pollution were most affected. In conclusion, both Bukit Rambai and Muar experienced moderate PM10 pollution and episodic haze. Improving air quality requires stricter vehicle and industrial emission control, reduced open burning, and continuous air quality monitoring.
Our second case study focuses on Hanoi, Vietnam, a densely populated urban city affected by traffic emissions and industrial activity. The study assesses the health and economic impacts of exposure to fine particulate matter PM2.5 in the population. To gather the data, PM2.5 concentrations were collected from city monitoring stations and combined with population data across different districts. The researchers estimated human exposure by age, gender, and location and calculated the associated health impacts, including premature deaths. In addition, the economic losses resulting from health impacts were assessed as a percentage of Hanoi's gross regional domestic product or GRDP. The study revealed that PM2.5 concentrations frequently exceed the World Health Organization's guideline of 15 micrograms per cubic meter, posing significant health risk. The exposure was linked to premature deaths, with higher impacts observed in certain districts and among vulnerable populations. Economically, these health-related effects are estimated to account for approximately 6.3% of Hanoi's GRDP, highlighting the substantial societal cost of air pollution. PM2.5 in Hanoi is a primary pollutant emitted from vehicles, industrial sources, and seasonal activities. Although this study does not focus on secondary pollutant formation, it underscores the importance of controlling primary emissions to protect public health and reduce economic burden. To mitigate these effects, researchers recommend reducing traffic emissions, enforcing industrial emission controls, and implementing urban air quality management strategies. Public awareness campaigns and continuous air quality monitoring are also essential to protect both the population and the environment from the harmful impacts of PM2.5 pollution. Thank you.
So now let's move on to case study 3. This case study focuses on air quality in Bandung, Indonesia, one of the major urban centers in the country. Urban air pollution is a critical environmental and public health issue, primarily caused by traffic, industrial activities, and biomass burning. To understand air pollution trends, researchers collected PM2.5 and PM10 samples using gigantic filter unit samples at multiple sites in Bandung. Sampling was performed once per week for 24 hours, several months. Selected filters were analyzed in the laboratory to measure mass concentration, lead carbon content, and trace elements including silicon, sulfur, potassium, calcium, iron, zinc, and lead. The results showed that the average PM2.5 concentration in Bandung exceeded the national standard of 15 micrograms per cubic meter. Black carbon accounted for 15 until 26% of the PM2.5, indicating significant contributions from vehicle emissions and biomass burning. Trace metals such as iron, zinc, and lead reveal additional pollution from industrial sources. PM2.5 is classified as a primary pollutant emitted directly from combustion sources, while some secondary pollutants may form in the atmosphere through chemical reactions. Black carbon is a product of incomplete combustion, strongly linked to traffic and biomass burning, and has both health and biomass implications. The environmental and health impact of high PM2.5 levels are significant. Residents in Bandung face increased risk of respiratory illness, cardiovascular problems, and long-term health effects. Children, the elderly, and those with pre-existing conditions are especially vulnerable. To mitigate this impact, several emission control strategies are recommended. First, implementing stricter vehicle emission regulations. Second, regulating industrial emissions. Third, reducing open biomass burning through policy and public awareness. Fourth, continuous air quality monitoring across the city. And lastly, adopting emission control technologies such as filters, scrubbers, and cleaner fuel sources.
In summary, the 3 case studies from Bukit Rambai and Muar in Malaysia, Bandung in Indonesia, and urban areas in Vietnam highlight the serious impact of air pollution on both the environment and human health. Across all locations, PM10 and PM2.5 were the main pollutants. These include primary pollutants directly emitted from traffic, industrial activities, biomass burning, and secondary pollutants formed in the atmosphere through chemical reactions, which further worsen air quality. Exposure to these pollutants contributes to respiratory and cardiovascular health problems, particularly affecting vulnerable groups such as children, the elderly, and people with pre-existing conditions. Although mitigation measures vary by location, effective emission control strategies, including regulating vehicle and industrial emissions, reducing open burning, and continuous air quality monitoring, are essential to reduce both primary and secondary pollutant levels and protect public health. Overall, understanding the sources, formation, dispersion, and health impacts of both primary and secondary air pollutants is crucial for policymakers and communities to implement targeted strategies for cleaner air and a healthier environment.